Before anything, I just want to encourage people to move a bit to the front because, well, there's only one slide. There's a flowchart that has a lot of smaller words. It will be easier to see if you sit a little bit up front. But just fair warning, if you can't see it, don't blame me, okay? If you decide to hide in the back. All right, so my name is Chiu-Ki Chen. Today I'll be talking about caching strategies for mobile apps. Specifically, native app, for example, on iPhone and Android. I will not be actually speaking on the platform-specific calls or functions or anything of that kind, but just want to kind of set the stage. You can use the same technique for HTML5, local storage, manifest kind of caching. I'm a little bit curious. How many of you are actually mobile developers? Oh, okay, that's almost half the room. So some of the principles that I'm covering are kind of common sense. You may be already doing that. I just want to provide a framework for thinking about caching. First, why do we need to cache? Because everybody knows that we are always connected to the internet, right? It's always perfect connection, never ever gets dropped. Even when you're flying. Well, actually now they do have Wi-Fi on the air, but it's not always there. And there are places like tunnels where the signals just don't penetrate. And anybody know where this is? Machu Picchu. You're like, well, come on, you're addicted to the internet if you need it at Machu Picchu. Just don't bring your phone. Well, but what if someone just wrote an app that describes all the ruins, the history, and you have this encyclopedia of information just in your pocket? If you don't have internet, usually you just don't have information. Somehow that's today's thinking, right? Like you have the internet, you have all the information, but it's perfectly fine if you have an offline tour guide that you can use for Peru. And of course, there's all kinds of other situations that you may not even think of that your user get themselves into. But don't blame them, blame yourself. You should make your app work even when there's no internet. And one thing that's very important to start thinking is think about the offline use case from the beginning when you are designing your app. It's much easier when you know that, okay, I am going to have partially my data that's from my local storage and use it instead of start from always fetching from the internet and have that flow and then retrofit it. And the side benefit is that if you do that, then even when you have internet, you don't call it when you don't need to. So your UI is actually much faster. This is the core of the presentation. I'm going to actually go through 4 different case studies of how other people use caching in their applications. But this is how I think about caching. When you have a mobile app, there's some data that you just ship with it that's compiled with your binary. That's always there. You can assume that you will always have that piece of data with you. And then after that, there's one tier of data that is what I call permanently cached, meaning that you fetch it from the internet and you stick it onto the disk. And you can assume that's always there, but that's data that you're using pretty frequently. So you want it to be there ready for you. And then there is a rotating temporary cache. For example, something like images is a perfect candidate. Maybe you have a photo album. You don't want to store all the images. What if this user has taken 10,000 photos? I mean, you can't stop them from doing that. So maybe you want to just keep the most recent 100 photos. And then as they scroll along, then you go ahead and fetch some more. So usually when things are temporarily cached, either you put it in a system directory that will get periodically cleaned, or you have a janitor process that go ahead and do a least frequently used cleanup. And then, well, some stuff just don't get cached. And I put it in red. Try not to do it. But I'll show you some examples when you just can't help but have fresh data. Now, how do you decide which tier to put them in? There are a few considerations. One is what I call first use, because users really don't have a lot of attention span. If you lose them in the first 2 minutes, you're gone. They will just uninstall your app, or it will just sit there. They will never touch it. So the first use experience is very important. You may want to bundle some data with your app, at least some placeholders or frames so that they know that something is happening. If you just have like a blank screen with a little spinny in the middle, they may wait for, I don't know, 3-4 seconds and then just go away and watch TV instead. So that's one big thing. Is like you want to capture them from the beginning that, okay, they will keep going and they get engaged with your app. And then, of course, the other part is just when they keep using it, what happens when they go offline? Like I said, sometimes the app doesn't actually need the internet all the time. You may want to refresh yourself from time to time so that you get relevant data. But most of the app actually can have a very compelling offline experience if only you design for it. So think about how they will use your data offline. And then there is data, and then there is data, right? There is something that is like the weather forecast. Well, I may cache it for just today. It's not actually relevant, the weather forecast. Maybe it says 30% chance of shower, and then today rolled along and it did not shower. Well, I don't care that it said it would be 30%. So for data that expires a lot, you may or may not want to cache it, and if you want to cache it, then you want to be aggressive in expiring it. On the other hand, maybe you just have a list of the United States of America's presidents. Well, that change every 4 years, maybe every 8 years. Go ahead and fetch that and just stick that in, and don't need to always, like every time they open the app, ooh, let me fetch from the White House what's the latest list of presidents. That's a little bit of an overkill. So you want to consider what data you are trying to cache. And then finally, like I was talking about the photo album case, storage is a big deal. Most of the time, you can just store it on the SD card, and people have pretty big SD cards. But for example, in Android, there is also what they call on-phone storage, and that could be small, depending on how recent the model is. So just be conscious of it. Caching is great, but caching to the point where they cannot install any new apps because you eat up all the storage space, not great. So just think about that. And then when you want to get data, simplistically, just, ooh, I call my server, and server gives me back data. But that's actually a lot more to it. So rule number 1, never, ever do it on the UI thread. Always have a background thread to do it, because otherwise, you're busy fetching the data, and people are clicking the button, and nothing happens. That frustrates people a lot. So always put it on the background thread so that you have callbacks when something happens, and fill it in. And by fill it in, I mean you initially have a frame. So for example, if it's a photo album, you just have a grid, and then you have little spinny things going on to indicate that something is happening. As each image come up, the placeholder get replaced by the actual image. So that is a much better experience than you just have this blank screen, and then you wait for all 10 images to come, and then bam, all show up. Again, this is a perception thing, right? You want the user to know that, oh, okay, the app is usable. I can click on buttons, things are happening. And another trick that you want to think about is think about breadth first. Again, the case of a photo album, you don't want to go ahead and say, okay, I'm going to take all the baby photos and then finish the baby photo one, and then go ahead and do my wedding one. You want to just fetch maybe just the cover picture so that people know that, oh, okay, these they will fill in. Because there's no point like getting all 100 pictures of the baby shower if the user actually want to look at the wedding photos. So go ahead and just think of what will be shown to the user first and fetch that shallow layer. And then if they're just on their screen admiring your layout or whatnot, you go ahead and fetch some more data so that when they go onto the next screen, it's ready to go. But think about breadth first search. And then finally, this is a pretty common trick. Have a splash screen. I will show you, actually I don't have a screenshot. I can show you later on my app. So I have this app which teaches children how to write Chinese, and it has a mascot, it's a monkey. So on the splash screen, nothing really happened. There's this monkey just swinging. And technically, I don't need a swinging monkey. But the reason why it's there is so that it just distracts the user while I go ahead and fetch data in the background. So that when they are ready, they click start. When they have done watching the monkey for that half second, there's already data waiting for them. So that's a nice trick. It's called sleight of hand, much like in magic. And finally, all I've been talking about is data that you have. What if the user is generating and need to go back the other way, upstream to the server? Again, very high-level principles. You want to store it locally first and then upload, even if you are pretty much always connected. This is just to guarantee that you will not lose the user data, right? So if you are already just like throwing it out to the network and then the network's gone, typing on the phone is not easy. You do not want to lose that data. And then another high-level principle is you want it to be append only, meaning that instead of editing, for example, the title of this hotel, and you have, say, like some local database, you want to keep a log of all the edits so that if there are, for example, 2 users doing the same edit at the same time, you can just merge it back in if there are concurrent issues, like someone write this part and then some other part gets happen. But all that high-level stuff doesn't really mean much. The devil is in the details. So we are going to jump right into the case studies. I'm going to show you 4 apps that have various degrees of needs for caching. The monkey is what I talked about. That's my app. That's called Monkey Write for writing Chinese. And then is that an owl? The one on the right, that's offlane. That is an offline screen reader, and the CEO, Roman's right here. So I'm going to have him answer some questions if you guys have questions for his app. And then this one is called Tripposle. It's an offline tour guide. They cache pretty aggressively. Pretty much what they want is, maybe you're going to Amsterdam. You get the guide, you download the data, you fly in, you don't have any internet, and you can just go around and navigate yourself in the city. And finally, does anyone know what that bluebird is? Yeah, so I'm going to actually use Twitter as an example as well. So let's go. Monkey Write. It's an app to learn to write Chinese. You may say, why do you need the internet at all? I mean, these are just a set of characters that you are practicing. So the way Monkey Write works is a freemium app, meaning that I ship with a certain set of characters, and then users can download new workbooks as they progress in the app. So the workbook catalog, what I call the bookstore, is the part that needs the internet, because I publish it from time to time. Right now, not that often, because I'm at the conference. I'm not actually producing content for the app. But the point being that is actually some data that will refresh, maybe every other week, depending on how hard I work. So I don't actually need to fetch it too aggressively, but it does need to be checked with the server from time to time. And then the way I tier it is like, I will go ahead and fetch the list of workbooks that is available and stick it into somewhere permanent. And then I have a temporary cache that I just store the image. Right now, there's not actually a lot of workbook cover images, so I don't actually need to do that, but it's just good practice so that when it grows, it would not, again, fill up the user's cache. And for things that are never cached well, if you are actually going to purchase a new module, you need to go ahead and go to the internet and fetch it, because by definition, you don't have it. So there's no getting around it. I will have to, when you want to go ahead and make a purchase, can't really do it when there's no internet. So I was telling you about the catalog. This is what I mean. So there is a nice bookshelf, which for things that are already installed is just like that. It's a nice book. And then for the rest of the stuff, I have like a price tag, and then you can go ahead and click on it, and it will bring you to Google Play. And then you can purchase it, and then it will get integrated to the app. This is the diagram that I warned you about. So people in the back, if you can't see, too bad. You would think that that's actually pretty simple, right? I was like, okay, fetch something from the internet. What's the big deal? Turns out I actually want it to pretty much always work. So I have this procedure. So the basic idea is very simple. I fetch the bookstore from the internet, from my server, and then I go ahead and cache it. So the next time when you come along, if the last time I checked the bookshelf was 3 hours ago, which is like more aggressive than I need already, given the current rate of publishing. If you only fetch it 10 minutes ago, there is no need to go and bother the internet. Just go ahead and read it from the local storage. And then I do the same thing again with the cover image. So just walk through, like pretend that I'm the app right now. So I come in and say, hey, do you have a bookshelf? Like, no, okay, and I'll go ahead and fetch it and then stick it in. But if there is already a bookshelf, then okay, I will go to the next stage, which is, do I have the images? So say somehow in between, the internet get cut, and I have the bookshelf, but I don't actually have the images. Well, no big deal, because when I ship down the bookshelf, I actually give a text summary so that I can just have a nice, I guess like a lesser experience. So it's not as cute as what you saw in the beginning. It only has a text description on the workbook, but it serves its purpose. It doesn't have just this ugly, you know how like when you go to internet and then there's an image that's not loading, you just have this kind of ghost image that's just like there in that place. I mean, this is a reasonable experience. And notice that the first one actually has an image because that one is installed. So the first one is already installed on your phone, so it can just go ahead and read it. So that one still has a nice image, but the rest of it just degraded into a text experience. And like I said, when you click on one of them, it will go ahead and bring you to the Google Play Store, and you can go ahead and buy it. I have no control on this experience. So when there's no internet, Google just say no connection. But at least the experience, when you come back, then it's like, well, okay, I'll go ahead and just play with whatever I've already installed. The app itself is still usable. There are components that doesn't work when you don't have internet. such as life. I cannot actually make it completely work when it's offline. So next example is an offline news reader. The way it's organized is that there are multiple news sources. So for example, you have CNN Money, you have New York Times, and things of that kind. And then each of them, you can fetch the articles, and then it will store it on the disk, and then you can read it when you're on the train, when you don't have internet. And there is actually quite interesting, because initially I was like, oh, maybe the sources are already prefetched and shipped with the app. Turns out there is not much to gain with that, and it's actually better to have the flexibility to be able to introduce new sources. So there is actually nothing in terms of the data that is pre-installed. Everything is fetched down and then stored. The articles and the images are also fetched down. So the idea of that is that, say there is initially 100 new sources and then some up-and-coming new sources there. So the client will tell the server and say, hey, I have these are the new sources I have. What new do you have? And then the server will send down the delta. But well, I wouldn't call it a problem, but there's an optimization that you can do, which is the first use case that I talked about earlier. You want a snappy experience. That computation actually takes a little bit of time just to diff, like even if it's done on the server. So the first time the app sends out and just say, hey, I have nothing, the server doesn't go and say, oh, let me diff something with nothing and then send something down. It just know that, oh, okay, I'll go ahead and have some like one prepackaged set that I'll just send down, because pretty much everybody's getting the same set. So that way you can make it even faster when you have one particular use case that's very common. Go ahead and do some server-side caching as well. And they also do a little bit of swinging monkey, their version of that. So to have a login screen so that when you're busy typing in your username and password, there's a background thread that go ahead and fetch down the sources and articles. This is how it looks like. And you can see that right now there are already a little bit of Spinneys going on. That is what happens when I was talking about the breadth first fetch. So you want to go ahead and fetch the highest level first and then go deep. So when this first happened, you see the article, well, not even the article, just the icon for the source, right? And then the article, the title, the text, and then the image comes last. Oh, I just said all that already. But okay, there's a little bit more detail here. So when the fetch is actually a round robin, what happened is that when you are fetching, you also need to think about the trade-off between a big batch size and a small batch size, because there's an overhead per connection, right? So you don't want to go ahead and say, give me one title, give me one title. Like, because each title is like such a tiny bit, you are just spending all the time just doing the network connection. So you want to do it in like a reasonable batch size. In the case of news articles, is 10. So you have 10 title plus article, because text is actually pretty easy to compress. So maybe you are like, oh, okay, I'll do the title first, and then article, and then images. Turns out you can just lump all the text stuff together, and then the images come as a separate request. You may want to experiment with these just to adjust the batch sizes and what groups of fetching you want to do. And this is just a screenshot to show you what happens when you drill one level deep. The previous screenshot has multiple sources. This is just a single source, which I don't know what it is, but we'll see. And now, when do you actually go ahead and fetch the new articles? Well, first of all, one design consideration you want to think about is how much control you want to give to the user. Is it completely transparent, things just magically happen, or you actually let them control how much local caching is happening? In the case of articles, some dial that makes sense is maybe the number of days of articles you want to be able to keep and the number of articles per source. Don't do things like, oh, do you want to store 120 megs of data or 248 megs of data? Nobody knows what that means. I mean, it may look like simple and easy, because for you just need to check the number of bytes, right? But what does that mean? Like, why would I want more or less? Think of it from the standpoint of a user. Like, what makes sense, what's useful for them? So in this case, number of days makes sense. And then for the case of offlane, it's an iPad app, which doesn't have background syncing capabilities like Android. So every time that syncing needs to happen, the app needs to be open. What they do is they put it on app launch. So when you open the app, they just go ahead and fetch stuff. And then while you are busy reading the articles, they go ahead and figure out whether you are still online. And if you are, every 5 minutes, it will try to fetch a new article. Again, this is a trade-off, right? Like you need to think about how often do breaking news happen. Do you want to actually, maybe for Twitter, you want to check more often. Maybe for news, you want to check less often. So that's the case for offlane. And then one final bit is there is actually offline generated data in this app, which is sharing. When you read the article, maybe you're on the train, and you're like, oh, this one is awesome. I want to share with my friends, maybe post it to Facebook or share it on Twitter. So the way offlane handles it is that you can go ahead and type in the comment, and then you can press, I don't know what you press, I guess share. You press the button to indicate that you want it to go out. And that, at that point, you have made a decision to share. Offlane will store it in the local disk, and then if there is internet, go ahead and send it out, and if there is not, try again some other time. The kind of a little bit of tidbit for this is the way offlane handle is actually pretty cool. Usually when you go to Facebook or Twitter, there is not a lot, you don't want to have like a gigantic link. So most of the time you want a short URL. But when you're offline, you can't really generate the URL. For news articles, you're sharing just the article link. So before offlane even send down the article and the images, know which URL you will potentially want to shorten. So go ahead and shorten that on the server and send it right down so that when you're composing the tweet, it's already there ready for you to go. So you know how many characters you can type. So that was pretty cute. And that's case study number 2. I'm going to take a little break. I'll be back. And then we're going to go right into Tripposle, which is the offline guidebook that I showed you earlier. And the way that app is organized is initially they started with one app per city, and then it kind of quickly got out of control, and also Apple doesn't like that. Apple doesn't want you to have kind of cookie cutter app just repeated all over the App Store. So then they moved on to this model when there's a single app that is the world guide. The list of available city guides and country guides are pre-installed, and for each of the guides there's a little bit of blurb, like an introduction, so that you know whether you're going to go ahead and download it. That gets shipped with the app. And then the individual guidebook, the individual articles, and the maps, when you decide to download a particular city, for example Philadelphia, it will go ahead and fetch it and store it permanently so that it doesn't get garbage collected or anything, so that when you are out of your Wi-Fi zone, you can still read it. And then they have a tiny, teeny bit of temporary cache data, which is weather and currency rate. Those data are fresh, basically, like I was telling earlier. There is no point telling you that it will rain yesterday. I mean, who cares, right? So this is what it looks like. That's the list of guidebooks. So everything like that, if you open the app when you're offline, you can still see that, oh, you can download Afghanistan, Albania, Algeria, and so on. But if you click on it, then you get the screen on the left, which is you can go ahead and download it. After you click on it, well, actually, these two screens are a little bit different also, because this one is on airplane mode, just to show that you can see this. That's when I started connected to the internet, and I click download, and then go ahead and download stuff. So I'm going to play a game of spot the difference now. Can you see anything else that's different between the two screens besides like the connection indicator and this button? Currency? You guys are sharp. That took me a little while because there are a lot of other things. Ah, right, the front row advantage. If I had a prize, you guys would not win anything. Right, so that's the currency rate. When you have no internet, it will still tell you that they use euro in Netherlands. But when you have internet, then it go ahead and fetches the latest currency rate. Currency rate doesn't expire as quickly as the weather. So Tripposle is just going to go ahead and store that until the next time you get an update, assuming that there's no economic crash or anything going on in the Netherlands, unlike the weather, which you pretty much know when that data is not valid anymore. Yeah, I said all that already. Next. This data is completely offline. Once it gets downloaded, you can use it, which is really nice. You have a nice map with all the different potential places that you want to hang out. This is the power of offline apps, right? Like You open the app, the data is right there, you can just get to it. You don't have to like stand around in the busy street corner in the Netherlands looking like a total tourist. This will make you look like just a dork because you're looking on your phone. But at least you will look as stupid that you're like standing at the street corner for 2 minutes waiting for that, stealing the internet from that library and trying to get as much information you can before you move on. But there are parts of this app that actually requires a little bit of internet connection. Notice the check-in button. What happens when you click on check-in? Well, you can go ahead and say, oh, the sunflowers are very nice at the Museum Van Gogh. And much like sharing in offlane, this is also saved locally. You upload it later. And when I say append only, it means that when you check in, you don't go ahead and uncheck in, or you go ahead and tweak the timestamp. I was not there at 5 a.m. What do you mean? I was there at 9 a.m. So this is an append only data. The user just type it in, press post, and then that's it. There's no need to go back and change anything. That is the kind of data you want to generate when you're offline so that you don't have to deal with concurrency issues. And another thing that they do is they allow the user to go ahead and edit the data if something is wrong. Maybe there's a misspelling, because the way Tripposle gets its data is actually from Wikipedia and all those open source data. So they want to be able to contribute back as well. And this has potential problem in terms of like two users being offline and editing it at the same time and then thinking later you need to resolve that. But the way Tripposle handles it is just treated as yet another source, because they are already merging Wikipedia with Wikitravel and with all these other things. So it's just yet another place where data come in. And they have some ranking algorithm and voting and whatnot, some sophisticated thing to decide what piece of data they want to go into the final shipped version of the guide. And as long as you have an append-only log of all the edits, then it's fine. Like maybe you picked the wrong one this time, but you can go ahead and rerun the processing and then pick the correct one. Maybe there's one user that is just change everything to balloons or something. And so every single museum in Netherlands is called balloons. You don't want that. You want to be able to go ahead and recover. So don't override your master data. That's, I guess, general life lesson, not just for offline generated data. And finally is Twitter. So this is actually Twitter for Android. This is the one I'm covering, just because I have a friend at Twitter who works on Twitter for Android. I think their iPhone apps is similarly organized because the server is shared, but I'm not going to pretend that I know how that works. So we're going to focus on the Android client. They actually pretty much cache everything. They want the app to be able to perform as much as possible when you're offline. But since Twitter is kind of a fire hose, there's so much stuff coming in, everything is just temporary cache. They have a fixed size cache to make sure that, like I said, it doesn't eat up all your storage so that you can't install any new apps. And the way that they do that is you have a fixed number of records. I mean, I call records because they could be tweets, they could be attached media like an image, they could be the number of retweet counts, there are other associated data. And then when they run out of space, you delete the old stuff. So it's the most, they keep the most recent stuff. And then when they fetch, they also want to make sure that you don't just hog the internet. So maybe I went on a backpacking trip for 3 months and I come back, I'm like, oh, let's see what's on Twitter. You don't want to backfill that 3 months of tweets. I mean, especially if you are me, because I subscribe to all kinds of stuff. There will be tons of stuff coming down. So they actually just go ahead and say, ask the service, hey, just give me X tweets. And newer than a certain time, right? Because maybe it wasn't 3 months ago that I last checked. Maybe it was 3 minutes ago because I was obsessed. So with the tool, you will be able to fetch some data that is actually relevant, makes sense, that's not going to clog your internet. This is what happens when there is a gap. So since it's a limited batch size, it's possible that the server will know, right? The server maybe know that, well, there is actually, since the time you told me, there is actually 5,000 articles, but I'm only going to give you a subset. This is actually a screenshot taken after I flew into Philadelphia. And Instagram just got bought by Facebook. So I bet that this gap there is filled with Instagram tweets, but I didn't see them because I was just like, okay, that's enough. I know that it got bought. But what happens when you tap on this? Then Twitter will go ahead and load whatever's in the gap. So this is the kind of user experience you want to give. Tell the user that there is more stuff, but I'm not doing it. If you want it, tell me. I will go ahead and fetch it. That way, lazy loading, essentially, right? If I don't need to do something, don't do it. This way, the user also feels that they're in control, right? It's like, okay, sure, there's some missing stuff. I want it. Give it to me. And Twitter, when you usually think of it, it's just text, but they actually have a lot of different pieces of data that put the app together. Profile photo. So every single tweet has a profile photo. It'll be silly if every time I said something, you go ahead and fetch my beautiful face from the internet again, because it's the same beautiful face. So they actually have a separate database that just saw, okay, Chiu-Ki looks like that. And then other people look like that. And then you don't actually need to fetch again the profile photos. That doesn't change that quickly. The text, like I said earlier on, it will be fetched in a certain batch size to make sure that you don't clog the internet and fetch this giant chunk of data that the user may or may not actually care. And then the rest of the stuff, like attached images, retweet counts, favorites, etc., they only get fetched when you open a tweet. And when I said open, it means like this. So you see that this is my tweet, what happened to Pluto, awesome picture, but it actually doesn't show the picture. When you go and click on it, then it expands out. I don't think you can. Can you actually see the picture? So this is actually all the planets going on a merry-go-round, and then Pluto is not tall enough, so it got left out. I thought that was really funny. But the point being that I don't want to actually go ahead and fill my main timeline with all these pictures, right? Because you may just want to quickly glance like what is happening, so they delay that fetch. If I never ever clicked on this tweet, that picture will not be fetched. I mean, why bother? If I'm not going to show it, why bother fetching it? I mean, there are some apps, maybe pre-fetching makes sense. If you know that the use case is most of the time they will actually go through one by one and step through. Twitter, usually people want a quick scan, so they made the decision to not pre-fetch and just go ahead and fetch a picture when you want to display it. Syncing. So since this is Android, there's actually background syncing, and there is a settings that you can set. You can ask Twitter to do it every 15 minutes, every 10 minutes, every hour, depending on, well, how often syncing makes sense for you. Maybe you think that if I sync too often, the battery will just die because I do all these different things. So you at least for Twitter, they give that control back to the user. Like you decide. But in terms that make sense, it's not like a little dial that's like, I want to sync every 15 seconds. I mean, you know. So this is actually a specific time interval that you can choose. You can also decide to sync it in the foreground when the app is open. So on app open, they also do a sync, but only if the data is too old. Too old in the Twitter world means 5 minutes old. So if it's within the last 5 minutes, it's fine. There's no need to go ahead and sync it. But if you are really obsessed, you can go ahead and pull and refresh. Probably most of you have seen that paradigm, where it's just a list of stuff, and when you pull on top, then we'll go ahead and load stuff. And then the open tweets that I showed you earlier with the picture, that is also cached. But that expires much faster than the rest of the stuff because that includes a retweet count and favorites. So that information is pretty much dynamic, right? Like at any given moment, any tweet can get retweeted. So that's why I was talking about the sync settings. So when you click on this, there's a drop-down menu that you can choose how often that you want to sync, and then there's just a graphic representation of that pull to refresh. And lastly is generating data when you're offline. You can actually write a tweet when you're on the plane, that's fine, when you have no internet connection. What happened is that tweet, again, you've seen it in the two other examples, right? It just goes down to the local database. And then for Twitter, they'll write it to the database and then they'll try posting right away. So that's not an extra thing that you want to be like, oh, save, post. So just click post. But when it failed, then it will go ahead and put a little bird in the Android notification bar telling you that, something went wrong. And then you can pull, and then it will bring you to the drafts folder, and then you can go ahead and issue a resend. Again, there is design decisions there, right? Because you can also just automatically resend for the user all the time until it succeeds. I like the way they handle it because the communication is clear. It's like, I tried, it didn't work. Now the ball is in your court. Do you want me to resend? Because sometimes you can just insist. It's like, okay, I will retry. Well, I'm flying to Hong Kong. I'm not going to arrive for another 11 hours, so you can keep all retrying all you want, right? So I like the way they handle it. For your app, it may or may not make sense. So again, just showing you how it actually looks like on the interface. I'm typing in my tweet, and then Twitter go ahead and try to send it. And then when it failed, because I very stubbornly put it on airplane mode, I made it fail, basically. I was not actually on an airplane. When you pull down that little bird, it will tell you, tweet not sent, save to drafts. And then when you click on it, it will go ahead and put the drafts folder, and click on it, and then you see there's a send all. So you can actually compose multiple tweets and then send them all at once when you get internet. So that's pretty much the whole presentation. Again, your takeaway, think about offline when you're designing the app from the beginning. That will make your life much easier. That will make your experience for the user much better. This is the framework that I use. I think it's pretty useful. What kind of data does your app need, and which tier should they go into? Thinking about the first case usage, how often you want to sync, how quickly your data expires. And I actually did quite some interview for the other examples, because I only have Monkey Write, I know like the back of my hand because I wrote it. But these are other people's apps. So like I said, Roman was here. He's the CEO for Offlane, and then I was also talking to my friends at the 2 other places. And thank you very much. The slides are online. You can go ahead and get it. It's a pretty long URL, so if you want to follow me on Twitter, I will send a short URL, and then you can get the talk that way. Right now, like if you just go to /talks, nothing happens. I should probably put a list of all the talks, and you can just click through. And if you want to learn to write Chinese, go ahead and scan that QR code and download it for Android. Android only, sorry. I didn't have time to implement iOS yet. But if you go to monkeywriteapp.com, there is a mailing list you can subscribe to. Thank you. Any questions? Yes?
We built an app where this is a really core feature, and I thought the talk was really good. It hit a lot of points. Some of the problems we still are trying to solve is when to prefetch. Like, obviously, if you're on a 3G connection, like, probably want to be very light. Maybe when you see more on a Wi-Fi.
Right.
Also, like, even though we were doing in our early builds, we're doing the background threaded for the pools. When we actually take that data and put it into the main database, it still locks the main database.
Oh.
So you see, like, they're like scrolling through a list.
Right.
It gets stuttery because it's, even though it's downloading on a background thread, it's still locking the UI thread through.
How large is your batch that it actually?
It can be quite substantial.
Right. Yeah.
And this is like one of those other cases. Like if we, I mean, we're hopeful to solve that background locking problem in another way, but
right.
It's also like I guess like the transactional nature of it too is like if you're syncing your data up from the server, if only half the sync was accomplished, like you should probably, like, depending on the data integrity needs of your app.
Right.
Like I can't trust it because like it changed like the session details, but not the
yeah.
project.
So I mean, again, it's hard to give generic advice, but what you want to do in that case is if you can make the transactions smaller so that you don't have to have this ginormous insert into the database when the data come back. That would be helpful, for example. Did you have a question up front row? You have your hand up? No? Maybe?
No, I'm just trying to make sure that I get the URL.
Ah, okay. All right. I'll leave it up, and if you have more questions, you can come on up front and we can talk. Okay, thank you.